Okay, this video is on matrix operations, and a matrix is just a way of organizing information in rows and columns. Now, the dimensions of a matrix are given by the number of rows in the matrix and then the number of columns in the matrix. So, for example, here's a matrix. I've got some information, some numbers that are organized in rows and columns. I see I've got 2 rows and I've got 3 columns. So this particular matrix we would say is a 2 by 3 matrix. 2 rows by 3 columns. Those are the dimensions of the matrix. Now, each of these numbers here in the matrix, these are all called elements. Each number in the matrix is called an element. So you can see for this particular matrix, I've got a total of 6 elements in the matrix. So any 2 by 3 matrix is going to have 6 elements. Now, in example 1 down here, you see it says for you to write the dimensions for each of these matrices. Now, if you want, you can pause the video here and you can try these out on your own. So the dimensions of each of these matrices, matrix A, I can see it's got 2 rows and 2 columns, so this is going to be a 2 by 2 matrix. Those are the dimensions. Matrix B, let's see, it's got 1, 2, 3, it's got 4 rows and only 1 column, so this is going to be a 4 by 1 matrix. By the way, this matrix it is also called a column matrix. Anytime you have a matrix that just has 1 column, that's referred to as a column matrix. Matrix C down here, let's see, I've got 2 columns and 2 rows and 4 columns. So this is going to be a 2 by 4 matrix. Remember, we always write the dimensions of the matrix as number of rows first by number of columns. Finally, matrix D, I've got 1 row and 3 columns. So this is going to be a 1 by 3 matrix. And similar to the column matrix, if I have a matrix like I do here for matrix D that just has 1 row, any matrix that just has 1 row is often called a row matrix. Okay, matrix addition. To add 2 matrices, you simply add the corresponding elements of each matrix. And now this word here, corresponding, this is a word that we're going to see over and over again throughout the course. Corresponding is just a fancy word that means in the same relative position. And I'll show you what I mean by that. Here are 2 matrices that I want to add together. When I want to add 2 matrices, I add the corresponding elements of each matrix. Well, this element here and this element here are what we call corresponding elements of these 2 matrices. In this matrix, this element here is in the first row and the first column. This element is also in the first row and the first column of this matrix. So these 2 elements we say are corresponding. They're in the same relative position. First row, first column in this matrix, first row, first column in this matrix. So I'm going to add these 2 elements together. -5 and 2 gives me a -3. This element and this element are also corresponding elements. This element here is in the first row, second column. This one's in the first row and second column. So these are in the same relative position. So those are corresponding. 18 plus 0 is 18. And I just continue like this. 17 and 5, gives me 17.5. 4 and 23, that's 27. 2 and negative 40, that's going to give me negative 38. And 21 and 3, that gives me 24. So now I've added those two matrices together. Okay, a couple more examples here in example number 2. It says add the following matrices if possible. So example 2a here, okay, I'm going to do the same thing that I did here, which is to just add the corresponding elements of my two matrices. So 0 and 7 is 7, negative 1 and 2 is positive 1, 13 and 2 is 15, 6.5 and 0 is 6.5. Now this one here, I notice that I have a 2 by 3 matrix and I'm trying to add it to a 2 by 2 matrix. Well, I can find these corresponding elements here and here, but this one doesn't have a corresponding element. The fact is that I cannot add these two matrices together. It's not possible to add two matrices together if they don't have the same dimensions. So adding these two matrices is not possible because the matrices have different dimensions. Since they have different dimensions, that means that there are going to be some elements in this matrix that don't have a corresponding element in the second matrix. So it's not possible to add those two. Okay, multiplication. To multiply a matrix by a constant, you simply multiply each element of the matrix by the constant. So for example, if I wanted to multiply this matrix, this 2 by 3 matrix, times this constant 6, I just multiply each one of the elements of this matrix by 6. So that's going to give me a matrix. And this element, 6 times negative 5, that's negative 30. 6 times 9 is 54. 6 times 11 is 66. 6 times 4 is 24. 6 times 2 is 12. 6 times 7 is 42. Now in your notes you can see there for example 3, you've got a couple of more problems to work out using these two matrices, matrix A and matrix B, and multiplying those matrices times a constant. I'm going to leave those two for you to work out on your own. Hopefully it won't be too difficult. You just go by this example that we worked here. So I'm going to go on down to this last section in this video, which is on vertex matrices. Now, vertex matrices just means that we have a matrix and the information in the matrix corresponds to vertices or vertexes. And the way that works is, for a vertex matrix, each one of the values in the first row is an x-coordinate. So all of these are x-coordinates. And all of these in this second row, all these elements are y-coordinates. So since I've got a row of x-coordinates and a row of y-coordinates, each one of these pairs of numbers represents a point, an x-coordinate and a y-coordinate, x-coordinate and a y-coordinate. I essentially have 4, since I have 4 sets of x-y coordinate pairs, I've got 4 points. So if I call this, let's call this point A, negative 2, 6. This will be point B. We'll call this point C and point D. Well, I've got these 4 points here, and I can plot these 4 points on a set of xy axes. So in your notes, you've got a set of xy axes that also has a grid on it, so you can do your plot is going to be maybe a little more accurate than mine. But essentially all I want to do is take each one of these points and plot it on my xy axes. So my first point, point A, negative 2, 6. Negative 2 is my x-coordinate, so let's see. Negative 2 and 6. going to be about right here. That's going to be point A. Point B is at 4, 5. 2, 3, 4. 1, 2, 3, 4. About right here. Point C is at 5, negative 2. 1, 2, 3, 4, 5. Negative 2. About right here. And point D, negative 5, negative 1. 1, 2. Negative 5. Negative 1. So here's point D. Now, I plotted these 4 points. Since we're calling each one of these points a vertex just means a corner point. If I connect up all of these 4 points, I connect up my vertices, then I have a picture. I've got a 4-sided picture. What we're going to learn is called a quadrilateral, a 4-sided polygon. And what we're going to be doing throughout the rest of this unit on transformations is we're going to be taking these different figures that we represent using a vertex matrix, and we're going to be performing different transformations on them, moving them around the set of coordinate axes. We're going to take a look at some more of those types of problems tomorrow in class.